Thank you very much, Maria. Right, 5-minute IDP. That's a crazy title, and it's a crazy time frame to have. You know, um, when I started thinking about this, I was thinking, man, you're in trouble. You're going to have a 5-minute IDP and at least 30 minutes of time. What are you gonna do? Well, I was thinking about actually brewing myself some ramen because that usually takes about 5 minutes if you have hot water. Um, And then I thought to myself, well, most probably you will have eaten anyway. So that's not going to work either. So I will somehow have to talk for 25 minutes. And then we do the 5-minute IDP thing. So, so much to that. I can actually give you some context around. So let's see. What will we do? First go over to the right window, or we will do nothing. So I have a lovely buzzword agenda prepared for you. So a few things we will look at today. IDP reference architectures, and 5-minute IDP architecture, and I will try to contrast them so you have a good idea what they can do and what they can't do. We'll be taking a look at score and score files and at resource definitions. And because that is 4 and 4 things on a slide always looks a little bit off, I needed a 5th, but I didn't put it there because who cares, right? We're going to do a demo, of course. So off to the races. First of all, I'm wearing this lovely Humanitec hoodie here, so I will have to tell you who we are and why we do this. Marketing makes me. So first of all, who are we? We are Humanitec, and we serve platform engineers with a build and blend approach. What does that mean? That means when we say we have those lovely products here and those OSS building blocks, that those are components. And what you usually do when you build an IDP is you design a platform architecture, and then you fill up the capabilities that you need with components. And we provide you with components, which means that you are actually building your IDP and you are blending the right components together so you get a fully featured and capable platform. We have a very strict process to get you there if you fancy to do that together with us. And we are doing this quite often. Lovely. So what is it that we do? Well, let's start at the problems, right? Because when you know what's wrong, you probably know how to fix it. So there is usually some perceived pain, and that is on the side where the developers live, missing self-service, cognitive load. So they need to understand too much technology and keep too much technology and implications in their head while fixing simple problems. Waiting times for infrastructure, for other people, for other systems, everything's slow. That's what we hear from developers. And if you look at the other side of the fence, the infrastructure and operations people who are actually behind this missing self-service, well, they are getting all of those lovely tickets because there is no clear boundary there of where configuration happens between infra and ops and developers. That results in insecure configurations, manual reviews that need to be done, and generally low standardization. All of that doesn't sound so great. So we thought to ourselves, what do you usually do? And when you look at the platform team, who does it? Well, let's look at some value drivers in this situation. So first of all, we identified one animal, the DevX platform engineer. He tries to be the champion of the developers, and he tries to remedy the situation that they are in with automation mainly. Because if you are missing self-service, what do you need to get there? You need a great interface, but behind that, you need automation. Because if you do not have a great button that gets you something, well, you're not getting anything, right? And behind the button needs to be to not be slow, to not have waiting times, needs to be a robot, right? And it's great to have that. But if you think about it, if you now have a button where you can just push and get all of that lovely infrastructure, well, most probably there is going to be more infrastructure. And now, if you look at the left-hand side of the problem, well, the infra and ops people, they get all of that onto their day 2 problem pile, right? So what they need to have for this to work is the other side of the equation. They have their own champions inside of the platform team, the infrastructure platform engineers, and their weapon is standardization. Well, because if you do not have 1,000 different types of one resource, but you have like only 10, and each of them has 100, yeah, not invariants, 100 instances, then you can actually take all of those 100 instances on one handle and mutate them at the same time. And that makes all of the problems go away. And if you look at those two combined, if you do it like this, then what you get is a better time to market, cost goes down, and innovation up, and everybody's happy sitting on top of this lovely pyramid. Okay, so that's what we do. That's the problem field that we play in. And we're going to build something that actually achieves that today and in 5 minutes. That's the problem. That's the promise. And I think I'm going to keep it. All right. So bird's eye perspective. How does this work? Apart from lovely slideware, yeah, we're going to see it in action today. But first of all, we need to understand what are the mechanisms at work. So the two things which are important in this case are that our developer who wants something is able to define all of his needs in an abstract way. And we have something called a workload specification named score for that. So instead of defining everything in minuscule detail, he can lean back into an abstraction and make an abstract request. And because that abstract request is lacking quite a bit of detail, we need somebody on the other side who fills in those details. Well, Entree Platform Engineer. He's the guy who defines how resources are provisioned and with resource definitions and criteria when those should be applied. Just essentially the configuration that goes up here into the Platform Orchestrator. And you probably have guessed already, that is the robot who is sitting behind the automation or behind the button that is the automation, who actually leads to these outcomes. So if we have the abstract request and we have the configuration, which specifies how to do that, the robot can work and we get application configurations created, infrastructure created, and workloads deployed, and everybody's happy. So let's look a little bit deeper. So this is a score file. As I said, this is a workload specification. So what does that mean? Well, the important parts are those two. We are talking about a product service up here. So this is what we are specifying. And down here, we have some requests for resources. So we want to have a Postgres DB named DB. We want to have an S3 bucket named bucket. And we want to have DNS named API DNS. Very creative today. And that is about the level of abstraction that developers enjoy. Yeah, I do not want to configure how much storage my database should have, how it should be backed up, if there is any special modules and any special database engines, retrieval strategies, optimizer hints, whatever. I do not want to do that. I just want to have my database and I want to dump my data there. So my application that I'm working on is finally stopping to have amnesia, right? So that's great if I can have that. But as I said, on the other side, there needs to be also somebody who solves the riddle. And probably there are also two things that you didn't notice directly, so I will point them out for you. This here is, first of all, platform agnostic. Nobody says you need to take this platform and put it behind that. And also, there is no notion of environments here. So I can have one score file and it's equally useful for local deployments, development, staging, and production. All right, if you hold that in your mind, the next screen will make a little bit more sense. if we've talked about score, we need to talk about resource definitions, because as I said, that is how somebody from the more infrastructure-oriented side describes how the robot should respond to this abstract request. And we are looking at a resource definition for Redis cache here. So the important parts are, we are looking at the resource definition for Redis, obviously. And this is using Terraform. So it is using an IAC language to actually mutate or create the resource that we are reasoning about. And the module that is actually doing the heavy lifting is living here in GitHub. I think that URL even works. You could look it up. And we have a criterion here that the environment type must be staging. So if I have different environments, I know if I'm going to staging, this is the Redis definition that should be applied. That might lead to the fact that in development, I have a widely different Redis than in production. Yeah? All right. So let's see how this clicks together. Once again, schematics. I have my orchestrator sitting here waiting for something, and I have the configurations. Yeah? There is quite a few of them. This time for context staging, we are looking at Postgres. Okay, great. So now comes the abstract request by the developer, which says, hey, I would like to have my Postgres DB. Awesome. All of that gets mangled through CI, forwarded to the orchestrator. The context is staging, so we know this one is going to be hit. Great. And what the orchestrator creates is a resource graph, and then it walks through the nodes, because this is a directed and acyclic dependency graph. We know where we can start traversing the graph and where we stop. We never need to visit a node twice. That's important because it's A, efficient, and B, it means once we have calculated the delta between two graphs, we know what we need to do. We do not need to touch everything. Okay, so if we now have that case and we want to update something, remember, we just looked at how Redis gets created in staging. Well, let's just add one. So we add 2 lines of code in the abstract request, cache type Redis. That goes once again through CI to the orchestrator. The orchestrator looks the resource definition up, and this time it's type Redis for context staging. That goes back. The orchestrator does its work, and we have a Redis node added to the graph. And when that graph is turned into actual infrastructure before the deployment, well, then we have a Redis cache being summoned. In this case, because we did look at the resource definition before, we know that Terraform was executed to create it. And that's on an abstract level how it works. There's a ton more I could say to that, but we are on a time budget, even if it's still a few minutes before I make my 5-minute run. All right, so let's look at what that means. Finally, a platform, right? We have some reference architectures for platforms, and I'm going to show you the one that goes with AWS usually. That's a lot of boxes on my screen, and it's bright all out of a sudden. Okay, so what are you looking at? You're looking at 5 different so-called planes. They start on the front end with the developer control plane, where you probably have a portal sitting as an entry, and you have all of the stuff that developers like to play with. Or we should probably better say stakeholders, because resource definitions are platform source code, but well, they go into revision control as well. Yeah, then you have the integration delivery plane, where basically the whole chain from initiation of something until its deployment happens. And then you have some flanking planes and the resource plane in the end, where stuff actually gets deployed too. It's great to have all that. You could schematically dissect that and look into the rhyme and reason for each of those boxes. But to be honest, we don't have time for that, right? If you want to put that out into the open, you need at least an hour. I would say you can do it in an hour, yeah, because all of that is completely terraformed. It's open source. You can take a look at it and you can evaluate it. But we are going to take a different route, right? We're going to do the 5-minute IDP first. And if you do that as well, and you're convinced afterwards, then this is your natural upgrade path. Why? Well, there's a lot of things on here. Let's look at the 5-minute version first. Yeah, speed is what we need. So 5-minute IDP architecture, probably a little bit more simple. So let's say you start with the cloud and your computer. And inside of the cloud, you have the Humanitec Orchestrator. And on your computer, you have a Docker daemon running. Do I have a Docker daemon running? I have a Docker daemon running. And just so you can see that, I'm going to start the dashboard. You can see I only have an Nginx gateway container and nothing else running here. Great. That gives me some leeway. Go away, dashboard. Right. So on top of my Docker daemon, what happens? I will start a container, and that container will carry all of the needed infrastructure, deployment commands, and everything to get myself the needed parts from the picture before. And first of all, this is going to start a Kubernetes cluster, because that's our deployment target. And then that Kubernetes cluster is hopefully waiting to receive a workload. That's what the Humanitec Orchestrator will try to put there. But obviously, there's a problem, right? Cloud and your computer, probably at least a firewall in the way. But what's also running on top of the Docker daemon is our beloved agent. And that is basically a reverse proxy utilizing WebSocket communication and opens a secure communication channel towards the orchestrator. So now the orchestrator is able to talk to your machine, or at least to the kind cluster running in the Docker daemon, not your host machine, obviously. Yeah, so now we can put that workload on top of the Kubernetes cluster, and we can basically observe how that all happens. Why? Well, first we're going to make the run, and then I will explain why you will not only see just the deploy of a container, why you will also see the infrastructure stuff. All right, check the clock. I have time. But 5-minute run, this is what I promised. This is what I try. And so you know that this is really nothing out of the ordinary. This is really nothing where I'm cheating. I'm literally going to take this link here. You will get it as well. This is a tutorial from our website. You have a great video from my colleague Johannes, who also explains how to do this. And I'm literally going to follow this tutorial. The only thing that I'm going to do is I'm going to change into my project 5 minutes directory because, as you can see, I use a tool called the which pre-populates my environment. Well, there's nothing magic happening here. That's just a little script that's being executed. It says my kube context. It reads a token so I can talk to the orchestrator. And it says my org, my app, and my env. Great. Nothing magic happening here. Directory empty. I'm not faking anything here. Okay, 5 minutes. Ready, steady, go. Copy and paste. So this is a Docker run command. I'm going to run the 5-minute IDP image. And this has a modifier which says pull always. So I'm going to pull a fresh copy from the internet. And here we go. The 5-minute IDP container is launched. Great. Okay, off to the next command. 0 install. I'm a naturally curious person, so let's cut this first and take a look if there's anything in here which could damage my machine. Create cluster, connect current container to the network. Okay, we're going to bridge this, Humanitec agent installation, and run Terraform. Okay, that sounds good. Let's do this. Okay, so now in the background, the Kubernetes cluster is starting. Control plane coming up. Need to be fast. So let's check the next step. Oh, one demo. That's like, okay, Kubernetes cluster started already. Successfully configured local. Okay, Terraform is running. 16 things to add. Okay, that's going to install the agent. That's going to connect the agent to the orchestrator. So we have our secured communication channel. And that's also going to configure the orchestrator in the background so that we can deploy some stuff to my local Kubernetes cluster. So it's creating resource definitions. And it's creating an Nginx release, of course, because I need. Hey, Giacomo, a little late. No worries. You're not missing anything if you joined just now. I'm doing my 5-minute run, and you will be able to replicate this as well. So let's execute the next one. I'm pretty sure that it does nothing that is bad. Okay, so what it does actually, it's deploying a workload. What you see here is pipeline running. And a pipeline is the functionality inside of the orchestrator that is able to steer how a point in code gets distributed to an environment. And now, after the pipeline has run, it has succeeded. This is curling for a request. Why is it doing that? Because it wants to find out when my workload is actually available. You can see workload is now available. I can open that URL. Hello world. So this is now coming live from my Kubernetes cluster running on top of my Docker daemon. And I think I even have a little bit of time to keep talking before my 5 minutes are gone. So let's use that time to some effect. I'm actually going to open the portal of the orchestrator. And this is what we have here. 5-minute IDP LHRRI. This is the deployment that we made. If I look in here, I can see our CLI was used to deploy it. Hello world is the workload that was put out. I can see it has a Postgres database. That's matching. It says here, this is an application talking to PostgreSQL 15.7. Yeah. And the question is now, hey, wait a moment, the Postgres database? Where is that coming from? All right, let's take a look. If I go to, oh wait, I can just follow this little blue arrow here and take a look at the resource management. Here I can see this Postgres is coming from here. And take a look at the matching criteria. If my application ID, so basically the name of my application is 5-minute IDP LHRI, then this resource definition should be used. And if I take a look at the configuration, I can see the template driver. That thing will create basically a YAML file that is used as a manifest and then put towards Kubernetes. And if I look into that here, I can see there is my container spec, and it's running the image Postgres 15. So basically, by using this resource definition, I tell the system, if the developer asks for a Postgres, then please respond with a Postgres container directly next to the application container. And that is totally awesome for situations like mine, where I do not have any infrastructure around apart from my local Kubernetes cluster. Yeah, it allows me to get experimenting really fast with real resources because they are real. They are just not cloud provider services. I would need a different resource definition for that. But well, if you have that, you can build that, right? And look, I think now my 5 minutes are over. I've even showed you around a little bit. The only thing that is left for me to do is, I have shown you that already, to run the cleanup script, which will say bye-bye to my Kubernetes cluster, run the Terraform destroy, so all of the resource definitions and the application is already gone. If I go to the resource management, those 5-minute IDP resource definition will be gone any second now. There we go. They are gone. So my orchestrator tenant is tidy now. My kind cluster is gone. I can safely exit out of the container and follow to the last step of the tutorial and remove the resources from my Docker daemon. And now it is as if nothing ever happened in the last 5 minutes. All right. So where does that take us? back to the start, basically. Now, this time I can say not a buzzword agenda, but things we have touched today. Now you know. You know what an IDP reference architecture is. It is a completely terraformed architecture, which is sitting at the ready in GitHub as open source. You can take it and you can install it. What can that thing do more than what you've just seen? Well, you can have real cloud provider resources. We have prepackaged one and so-called resource packs, so you do not need to learn how to write a resource definition from the get-go. You can just use that and start. But it's going to take longer. You're going to have a higher invest because you need a cloud account first. You're going to spend real money on infrastructure because cloud providers want to have some money for the services they provide you, right? And it's generally going to take longer. You also know what the 5-minute IDP architecture is. It is, in contrast to that, the cheapest and quickest way to actually experience what an internal developer platform might look like, what a platform orchestrator really does, and if that component and that technology, that way of life, or that way of living is something you would like to have in your future. You have seen a score file. I can only encourage you to take a look at the project, score.dev, because that's open source. It's on its way to being donated to the CNCF. It's platform agnostic. It could be in front of your platform if you use an orchestrator or not. Yeah. And it's a lovely piece of software. And you know what resource definitions are. These are the configuration of the orchestrator. All right. 30 minutes. I'm done. Which brings us to the point in time where you can, as Maria asked in the beginning, put some holes into me by asking deep technical questions. And so you have something to do while you ask those questions. I have put some URLs up here with QR codes and everything. So one is the 5-minute IDP, and the other one is the Platform Engineering Slack. I can only encourage you to join Platform Engineering Slack because that's an awesome community. You got any question, just ask. You can find me there at Jamie, and I might even answer. And yeah, I think I'm done for the day.
Perfect. Let's get started with the questions. Thank you so much, Clemens, for keeping it to 5 minutes almost. How can you monitor and divide costs between teams?
Well, that's a really good question. And there are some, I guess, obvious answers to that. I mean, how cost management works is pretty much a given in cloud infrastructure as well as in Kubernetes clusters. What you do is you tag resources and you give them the right tags so you can identify and trace back like a breadcrumb trail to where these resources belong. And most probably you have a cloud costing solution. There are some great ones like OpenCost, for example, which are able to work on those tags, which then hopefully can be translated via a taxonomy to your cost center organization. And then you can take all of the costs that are attached to those tagged resources and factor that back to the cost center where they belong. That is the most easy way to do it. And generally, I think people do it like this. If you think about doing that without a platform orchestrator, that's completely possible. But then you have to be really diligent on tagging things consistently and teaching people how to tag. If you have a platform orchestrator, that's a lot more easy because you can, while these graphs are constructed, inject your taxonomy with all of the text and annotations that you need from the sideline. So the developer doesn't need to think about it. He doesn't need to get it right because you can automatically inject the tags while the deployment is happening. All right. I hope that was everything that was asked for. If not, please shoot another question to the aspect that I didn't cover.
Nice. I would like to implement a use case layer plus a multi-cloud cost optimization recommendation engine before the abstraction and resource layer. Is this a design you have seen?
The answer is yes. There are even solutions out there which do exactly that, yeah, which basically take the wish of the developer and pre-calculate the associated cost if you would push the button to deploy that thing. And you have more sophisticated solutions which calculate the cost for for example, the major cloud providers or your in-house cloud provider, aka the data center, and then give you a choice of where you actually want to run that. Yeah. There are solutions that do this. If you want to build that on your own, obviously you can do that as well. I don't remember if I have seen an open source project do that. There is something called the FinOps Foundation. And if you go to their site, they actually have almost any tool that goes into that direction on the register. So basically the cloud native landscape of FinOps, yeah. And if there is an open source tool which does it, it should be registered there. So take a look there. If that exists, then you could participate, or obviously you could build one yourself. And yes, you could also build one that is basically executed before the orchestration layer of a platform and works together with it, so that what your tool calculated is basically taken as the deployment target for the orchestrator to facilitate the deployment. That would be a cool solution. I would love to see that. Great.
Do love interesting architectures, Clemens, no? I'll
Yes, I
just
do.
drop in the link to the platform engineer Slack in case it's better for someone to click on the link rather than scan the QR code, but this is the same one as Clemens has on the slide. The next question is, can I use Pulumi instead of Terraform?
Of course. Go ahead. Knock yourself out. So when it comes to drivers, we support basically all major open source languages. Or did I say open source? I meant infrastructure as code languages. And Pulumi is one of them. Go ahead, knock yourself out. Does that always make sense? Maybe, maybe not. Depends a little bit on your case. I always eat pulumi with a little bit, with a little grain of salt. Why? Because it is not so long that basically pulumi was just an outer shell to give you a domain-specific language inside of your programming language that would call out to Terraform to do the job. And in large parts of Pulumi, it is still so that they have not yet implemented their actual own engine, but are using Terraform under the hood. Then it's always a question, do I rely on a domain-specific language or do I take the thing on its own? It's a valid choice to make. But well, whatever you do, we could do both.
Well, next question is, so you want to simulate the potential cost, CO2 footprint, etc., before you deploy a resource Kubernetes cluster. Can you simulate that with your orchestrator?
Yes, you could do that. You have seen a pipeline at work. I mean, you have seen the log output of a pipeline at work. A pipeline is that thing that get executed around a deployment. And around means that before and after deployment, you can do things. And we do not have a module which does what you describe. But if you have a module that does what you describe, you could actually call out to that module as the part of the pipeline that gets executed before the deployment, and then take that knowledge and insert a verification or a validation step where you say, okay, I need somebody to log on to the orchestrator and either approve or deny this deployment. And at that point in time, the information which is associated with that, the potential cost and the CO2 footprint, etc., they are available and can now be displayed to the reviewer and he can review that and say, yay, I wanted this deployment to progress, or nay, please stop it right there. The cost is outrageous, or who wants to pollute the planet like that? Please stop. Would be totally possible. I have not yet seen that because, frankly speaking, most companies work in a different way. They are like American cops, yeah? Shoot first, questions later, deploy first, then evaluate where to factor the cost. If the cost is outrageous, well, the one who deployed the stuff in the first place should then please collect it again. That's what I see most in companies. It would be great if it would be the other way around, because I think people would probably reconsider a few questionable choices when the outcome would be put plain in front of their eyes before buttons are pushed.
And going back to that question around multi-cloud cost optimization recommendation engine before the abstraction and resource layer, Poya is asking whether or not you can name some solutions that you know.
Right, the one that I always name is open cost. Yeah, pretty simple. That's an open source project. It is able to monitor cloud cost. It is able to monitor Kubernetes cost, and it is able to organize chargeback according to a taxonomy, which is like the basic framework of all of that, right? And given on the cost that you get out of there, you can obviously also run optimizations, but that's a different type of animal. I can only once again suggest that you go to the FinOps organization or the FinOps Foundation. Sorry. They have all of these tools on register, and they have a much better understanding of all of the tools put out in a simple landscape that you can traverse than I could try to put down in 2 minutes. If you want to have a more elaborate chat on the topic, I would love to do that as well. But then you please have to join Platform Engineering Slack and ask me there, because then we can take the discussion to be a little bit more asynchronous, and I will have time to write a good answer.
And then also, I would suggest, that's a very good point, Clemens. There is a question from Niels. What do you think about open cost versus kube cost? So I would suggest we take that question as well to the Platform Engineering Slack channel, if you don't mind.
Right. That one is that is going to be a big discussion, because funny enough, both projects they eat each other, so to speak. And the most of the committers of the one project are also committing inside of the other. One of them is more commercially oriented, but is sponsoring the other. It's a funny situation. There's a lot to be recognized between those two projects, but it's more open source drama than anything else. Yeah. I think you can roll with each of them. And if you want to have a deeper discussion, join Platform Engineering Slack and drive me crazy. I'm game.
Next question is, could you replace CD part with Argo CD, for example?
Yes and no. Why yes and no? Yes, you can have Argo CD as part of the CD process, but you cannot replace the whole process, because obviously you need to generate something that Argo can actually deploy. And there are even good reasons to do it like this. If you, for example, want to have all of the secrets inside of your network, you need something that actually hydrates the deployment manifests in your network. So what do we have in stock for that? If you want to run it like this, we have something called the GitOps mode that you put the orchestrator into, which means it will only render custom resources that will then get persisted in a Git repo. You use Argo to pull that into your cluster and then let the right operators with their controllers work on the custom resources to actually materialize the deployment and the infrastructure. For that, we also have an operator, obviously, which takes over that job and can then call out to the drivers that you can also self-host in your own network. and can talk to your desired secret manager to get all of the right secrets and hydrate the manifests and create the outcome.
Nice.
Sounds
Is
good.
it? Mhm.
Haha, I'm reading the last one myself. Hamid, great question as well. Thank you very much. I've shown you one reference architecture. That was the one for AWS, but we have one for each of the large cloud providers. We have one for OpenShift. And if you ask nicely or threaten enough, I might even do one for VMware. Sorry, I now have to say Broadcom. So there are basically no limits to what the orchestrator can be triggered from, call out to, and be utilized on, I would say. So Azure and Azure DevOps are really not a hurdle at all. There's a predefined reference architecture for Azure. There's a resource pack for Azure. You could be up and running with Azure in, I would say, 1.5 hours if you're good in Terraform.
Nice. And yeah, Clemens, we forgot to mention PlatformCon that is next week. So if you still guys haven't registered for PlatformCon, you still have time to do so. Just go to platformcon.com
Or
as
platform.
Clemens
.com.
shows you right now.
Don't go to platformcon.io. I always do that mistake. It's the wrong thing. Go to .com.
You got okay, funny joke, I have to admit, maybe. Yeah, but if I assume you guys are interested in everything around platform engineering, DevOps. That's one of the biggest conferences within the space. We are going to have lots of amazing speakers, 5 days. It starts on Monday, June 10, as Clemens shows you. Everything is like free. It will be streamed on YouTube, so you can like consume the content as you feel comfortable and as you work through your day. And you want to talk about your workshop, Clemens?
No, I just want to promote it shamelessly. So if you can't get enough from my ramblings, just go to Best Practices in Infrastructure Platform Engineering, hosted by yours truly.
Yes, at 3 p.m., right? On June 11th.
Yes.
Exactly. Yeah, but technically you don't have to be there at 3 p.m. You can just like sign up for PlatformCon and then attend or like watch any of the workshops. And we're going to have events in person all around the world. The one biggest one will be in London on June 12th on Wednesday. So really, really looking forward to, I hope, meeting some of you in person if you get to any of these watch parties. But with that, I don't see any other questions. So as always, we are going to follow up with the recording. The questions that you guys had, please put them in the Platform Engineering Slack channel. And Clemens is very, very happy to debate and provide long answers to that. What's the best next step, Clemens? I forgot to ask you. That's my favorite question.
Yeah, well, obviously, go to the 5-minute IDP tutorial and make your own 5-minute run. Experiment a little bit with that thing, take a look, see how it clicks together, and decide if that is something that you like. And if you do, well, then just click the link behind the I want to know more button, so to speak. Yeah, and sign yourself up for an in-depth deep dive on the technical side of that stuff with me or one of my colleagues. And then we see what we can do.
Amazing. Cool. Hope everyone has a great end of the day and amazing rest of the week. Hope to see you guys at PlatformCon next week. And thank you so much, Clemens, for leading this session. And yeah, see you guys. Thank you.
Thank you very much, Maria, for hosting this wonderful how to turn 5-minute IDPs into 50 minutes.
You're
What difference
slightly
a
off
zero can do.
time.